We got a question from Examos about an example challenge from the Absolute Coordinates mini-zine, which I'm going to take a look at now. I'm going to try to take it slowly this time. People have told me that I speak too quickly and I move too quickly through the different examples, especially when I'm coding. So I'm going to try to take it slowly, but I find that difficult to do. So you can always just rewatch parts of the video. You can, of course, also slow down the video if you need to. And then you're welcome to post comments and questions, and I can always make another video. This is the example that I'm going to look at. It's towards the end of the zine. Let me zoom in on that. Okay. It says, a square turned 45 degrees fits perfectly inside a circle that has a radius of 60 units. The bottom of both is at the coordinate 0, minus 60. So what is the difficulty in this challenge? Is the fact that you have been given information about the circle, but you have to calculate some information to be able to draw the square. And what do you need to calculate? Well, it's that distance there, the side length of the square, because you don't know what that is, and you need that to be able to move on that line the correct distance when drawing it. Now, the approach that I'm going to take is not to go and do the circle first and then do the square. One could obviously take that approach once you know this distance, but the approach that I'm going to take is to do 1/4 circle at a time, come back, down, and then move on and do the next quarter circle. The reason why I'm going to do that is just because it's going to make it easier to illustrate specific concepts that I want to show you. There's many ways to go about doing this. The most direct way would be to calculate that distance on paper and then use that value. So let's do that first. It is a bit of a crazy thing. It's going to seem over the top because we're going to do some maths now, but that's the whole point, is that we're going to start like this, and from there it's going to become simpler and simpler as we move over to Python doing the work for us instead of us actually doing that work on paper. But let's start on paper. For that, we need to look at this example and see that here we have a 90-degree triangle. You see there's the 90 degrees in the middle. And there's one side, another side, and we're going to use that to calculate that distance. I'm sure most of you have done this by now by using the Pythagorean theorem, but let me just do a quick recap to show you. When you have a 90-degree triangle, then there's a relationship between the sides. So let's call this side 1 and side 2, and this is called the hypotenuse. So the relationship between those those sides, is that h squared is equal to the first side squared plus the second side squared. So if you know these values, you'd like to work out what the hypotenuse is, the length of the hypotenuse. You just square root both sides. Okay. So the hypotenuse is the square root of the first side squared plus the second side squared. Now, when you look at the example, you can see that our side 1 has the same length as side 2 because they're both just the radius of the circle, which is 60. So let's simplify this equation. Instead of saying side 1 squared and side 2 squared, I'm just going to call them both a side because they're the same value. So the hypotenuse equals the square root of side squared plus side squared. So that's equal to 2 sides squared, square root of that, which equals to root 2 times the square root of side squared. Now obviously when you square something and then take the square root, that's just equal to that thing itself. So that's square root 2 times the side length. Okay, so what are these values? Square root 2 is about 1.4 and side has a length of 60. So that should give us a value of about 64, about 84 point something or other. Okay, now take a calculator and work out those values. That gives us a value of 84.85. Now you can take this value and use that value in your code. So let's now get to the coding. So import turtle. Let's move down to this point at the bottom here. So let's lift up the pen up. Sometimes I'm going to use shortcuts. So for pen up, the shortcut is PU, pen up, turtle the pen up, and then let's go to that point. These commands like go to you would have seen in the absolute coordinate scene. So that point is at 0 minus 60. And then let's put the pen down again, PD for pen down. So the turtle is now at this point, right? And so like I said, I'm only going to do a quarter circle at a time. So let's do the first quarter circle. Turtle.circle. The radius we know is 60. And a quarter circle, we can either just write 90, but how did we get to 90? Well, that's 360 for full circle divided by 4. Okay, so I'm just going to leave it as 360 divided by 4. I sometimes prefer doing this to just the value of 90 because then it's quite clear what I'm doing there. Okay, so that then takes our turtle all the way around, drawing that quarter circle. And then we'd like it now to move back to that point. Well, we've worked out what that distance is, and we can just use it directly. It was 84.85. So we can make the turtle turn. So once it's done the quarter circle, it's pointing upwards. So I need to turn 90 degrees this way, and then another 45 that would point it down this way again. Okay, so let's turn left, say 90 plus 45. This might be also a good illustration of the operator zine, where instead of me just using values there, I show the calculation to myself when I'm reading my code. Then it becomes obvious what I'm doing. But also, I'm letting Python do the calculations for me as much as possible, rather than me constantly doing the calculations and just stuffing values in there. So yeah, it's quite clear. I'm turning left 90 degrees and then also another 45 degrees instead of just writing 135. That's a lot easier. Sometimes those values aren't so clear. And then if you could see your calculation, your own code becomes quite clear to yourself in future. So now we need to move forward. And that distance was 84.85. So that should now take us back to that point with the turtle facing down. So let's run the code and see. Okay, there we go. Obviously, we just need to repeat this to do the other quarter circles. So now we're facing down and to the left. So we can turn either left or right. Let's carry on turning to the left. 45 has us pointing down. And then plus 90 has us pointing to the right again, the direction we were facing to start off with. And now if we do another circle, that's going to get us to the point, the starting point for the next quarter circle. Okay. So once we're at the point of the next quarter circle, we can just repeat the same thing again and again and again. So I'm going to copy paste. That would give us the second quarter circle, and the third, and the fourth. Let's run the code and see. There we go. Okay, so that's one approach that you can take, is we did the calculation ourselves on paper, and then using a calculator, we got the distance of that, the length of that side is 84.85, and then we used that value directly in our code everywhere, as you can see. Okay, so that's the first approach. It's very direct, and you have to use a calculator to do it. It doesn't really work so well. So how might we go about improving our approach? Well, we're using a computer, we're coding, and a computer calculates. So let's use it to do that calculation for us, rather than us doing the calculation on a calculator and then entering that value. Okay, so how might we go about calculating that? So there's multiple ways you can go about that. The first might be the math module. The math module, inside the math module is a function called square root. And we want the square root of 2, which we can then times by 60. So I'm just going to print out that value, just so we see whether we get the same result, which should be 84.85. And we do. You see at the bottom there, 84.85. Okay, so that is a better approach because now the computer is doing the calculation for us. We don't have to calculate it ourselves on a calculator and enter that value. So now we can use that value everywhere we like. So either we could simply have it calculated for us and spit out the answer. There it is. Then we copy paste that answer and then paste that everywhere into our program when we're writing it. Okay. But that's similar to before. We're just not copying it from a calculator. We're copying it straight out of a computer, which helps a bit, but it's still not that great. A better approach might simply be to use this value directly, right? So instead of us getting the answer, printing it, then copy pasting the answer, we just use that everywhere. So instead of writing 84.85 everywhere, we just redo that calculation everywhere instead. I don't need to do this print anymore. So let's see if it still happens. Okay, so it still works. But this now is a lot better because we are letting Python do the calculation for us. And if we wanted to change the size of the circle, for example, we don't need to go to the calculator again and recalculate and re-enter that number each time. We simply have to change the radius and the calculation is done for us. So that's much better. Okay, another approach, instead of using the math module and the square root function inside the math module, would be to use a special operator that does powers. I'm going to remove the math module there. Okay, so this is going to give an error now. I'm going to fix that just now. Just want to explain first. So we have different operators. You guys are used to the plus, minus, divide, multiply. Now there is another special operator which looks like that. It's two multipliers in a row. And what that does is it's the power. So if you do 2 to the power of 2, it gives you an answer of 4, right? You see 2 to the power of 2 or 2 to the power of 3 would be 8. Okay. So that's power. So a different way to write a square root of something is to the power of a half. So if we want to calculate what is power 2 to a square root of 2 is 2 to the power of half, we could just do that. I'm going to print that quick. You see there. And then if we multiply that by 60, we should get our same old answer, 84.85. There we go. Okay, sorry, it's complaining about the math not defined because I removed the math module here. So we still get the same answer. So that is better in some senses in that you're using the Python operator instead of using the math module. So your program is smaller because you're not importing the entire math module into your program. You're simply using the Python operator. And then instead of math.square root everywhere, we could simply use the Python operator directly. Okay, we can remove the print. This should still give us the same result. Okay. Now, how can we improve this? This is still a manual Pythagorean calculation, right? When we looked at this problem, we saw that this distance is something we need to work out ourselves. And we saw that we have a 90-degree angle here. And so because of that, we could use the Pythagorean theorem to figure out what is the length of the hypotenuse. We do all of that ourselves, and then we use that value. But is there not a better way to go about doing that? What if you have a problem where it is not actually a Pythagorean triangle that you have here with a 90-degree angle? Then it becomes more and more difficult to work out that distance. So can't Turtle maybe tell us what is a distance? I mean, Turtle is the one drawing all of these things, so surely it should be able to tell us what certain distances are. And it can actually do that. It's got a distance function. And if you give it the destination coordinate that you want to go to, it'll tell you the distance from where it is currently to that point. So let's go about using that instead. So I'm going to remove all of this code just to simplify our thinking again. Okay. So pen up. Then we go down to this point here, 0 minus 60, and we put the pen down. Okay, so we're at this point now, and we're looking to the right. Now we do the circle, a quarter circle, so that draws it to there. Now we'd like to move to this point. Okay, So we can, once again, just print out the distance, right? Let's do that first. If we do, we ask Turtle to give us the distance by using the distance function, and then we print that value. So what distance would we like to know? Well, we're now at this point, and we'd like to know the distance from there to this point at the bottom, which is coordinate is 0 minus 60. So if we give it the destination coordinate, then it's going to tell us what is the distance from there to there. Let's print that. It should still be the same value, and it is. Okay, so that is another way that you could use just to get that value, and then again, you copy paste this value into your code when you're coding and use the actual value hard-coded, but that's not a clever approach. With Turtle being able to give us the distance and being able to calculate that for us all the time, let's just use that, right? So there's another function that we could use, and that is a Turtle function called towards. So at the moment, once our Turtle moves from here to there, it's pointing upwards. But we wanted to move from there to here to draw this line. So we need to change that angle that the Turtle is facing from that direction, or wherever it might be, to this direction, facing this point, so that when we move forward, it moves towards this point. And then we can use this distance that we're calculating for it to move forward that distance to reach that point. So that function that I'm talking about to get a direction from one point to a different point is the towards function, right? So that gives us the angle or the heading, the overall angle that Turtle should be facing, right? Or that the direction from one point to another point, from where the Turtle is currently to where we want it to go. And we wanted to aim towards that point that we want to go to. So where you're at, we want to aim towards that point. So we are asking Turtle from this point, right? If I want to move towards that point, what is this overall heading that I should have? So let's print that out before we print out the distance. Okay, and it's telling us that that angle is 225 degrees overall. Okay, so now we want to use that. How can we go about using that? We want to change Turtle's heading to be that answer that we got. So let's take this, instead of printing it out, let's change the Turtle heading to be that angle that we just calculated. I'm just going to comment that out for now. Let's take a look at what the Turtle does. Heading takes 0 positional arguments, 1 was given. No, okay, sorry. The function is actually set heading. Yes, there we go. So you can see at the end that Turtle changes its angle and is now facing towards this point, which is exactly what we wanted. Now when we tell it to move forward, how far should it move forward? Well, we can start off by having it move forward. Let's just have it move forward, let's say 20 or something, just so you can see. You see it starts moving in that direction, but how far should it go? Well, we calculated that distance, or rather, we had Turtle calculate us that distance. All right, so let's move forward that exact distance. There you go. That's exactly what we wanted for our first quarter circle. But now, if we want to do the other quarter circles, it's not so straightforward. We have to turn the Turtle. So left 45 and then another 90. Now it faces back in the direction that it started off with, facing to the right again. We can do another quarter circle to get us to the start of the next quarter circle. All right. But this time around, when we want to figure out the headings and how far it should move, we have to change the coordinate that it's going to, because it's no longer going from there to here. We're going to do a quarter circle, and then it must go from the top to the right. So that's a bit of a mission, because now we have to change those values. Okay, so next time around, we want it to face towards the point on the right, which is the point 60 on the X, 0 on the Y, and then move the distance from the top to that point. Okay, so for each quarter circle, you have to now customize that value in there because you keep changing what the point is that you want to move to. So that's not great. One thing that we notice here is that the actual distance is always going to be the same because this is a square. So that is another way we can improve this, is by you reusing that distance instead of calculating it each time. We can't do the same for set heading in this example. So this approach of using set heading and moving forward is maybe not a good approach. Our earlier approach was a better approach. But at least for this, we can reuse the distance. So instead of recalculating each time, we understand that squares have the same side lengths. So let's just calculate it once and then save that distance. Okay, so how do you save a value to reuse in other places? Well, you save it into a variable. What can we call it? Let's just call it S, or we can call it side, whatever we like. So instead of recalculating each time, we can just use side. Python will look inside the side variable and see what that distance is and use it there. And this time around, we don't need to calculate that again because squares always have the same side length. And so on. Now, let's just go back to the zine. We've covered all of these things now. Printing a result and then copy pasting that into your code, or doing the calculation and using that result directly. Saving the result into a variable to reuse. And now let's go on to creating a function. So what's happening in this case is that, like I was saying now, we have to change this each time, the coordinate that we would like to move to. So we have to set the heading for this point, and then next time around set the heading for that point, and then that point, and that point. So that isn't great. So what we'd like to do is to save the heading, save the X and Y coordinate, and then do our movement, and then go back to where we were. So if we can save that X and Y and coordinate and the heading, then we can go back to that point and change the heading back to what it was before we move on to the next thing and repeat the process. Okay, so let me illustrate that. Okay, so we're still going to do pen up. Move the turtle down to this point here, the bottom, the point 0 minus 60, and then put the pen down. Now, let's save the X coordinate of the turtle into a variable called X. Of course, we can call it whatever we like, but X just makes it easy to remember. You do that with Turtle's XCore function, as you would have seen here in the code there. We can also save the Y value. Let's save it into a variable called Y, because that just makes it easy. Let's print those values so you can see what they are. Now, it's always a good idea to first think, what do you think they should be? Okay, so what is our X coordinate at this point? Well, it's 0, right? That's where we move to. And what is our Y coordinate? That's minus 60, because that's the point we move to. So we expect this to print 0 minus 60. And it does. Okay. Now we'd like to save the heading as well. Let's just call it H. And you can do that. Look in the code here, it says the heading function. Okay, so let's print H as well. So the heading is 0. So by default, when turtle starts, it faces to the right, and that is a heading of 0. So what we'd like to do now is to draw a quarter circle, and then from wherever we might be, but that's going to be that point, of course, is to then move back to the X and Y coordinate that we saved. And then turtle is not going to be facing in a wrong direction. Then we're going to set the heading of the turtle back to what it was when we were at this point, which was facing to the right. Okay. So let's do our quarter circle. Okay, radius is 60. and it's a quarter circle. Then we tell Turtle, after it's done that, to go to the x coordinate and the y coordinate that we saved when we were here. Okay, let's run the code to see that happen. Okay, but now you see that the heading isn't necessarily correct. The heading is now pointing up because that was after the quarter circle. So we can change the heading back to what it was by using the set heading function, and the value that it had was h. Now it's back to the heading that it had when it was at this bottom point. Okay, so this is a nice algorithm for a quarter circle. Now we'd like to repeat that for all the other circles, or other quarter circles. So let's go to the start of the next quarter circle. That's what that line does. It just draws a quarter circle again. Okay, and now we can go through this whole thing again. At this point now, we save the x coordinate and the y coordinate and the heading of the turtle, do another quarter circle, and then move back to those values that we saved, set the heading to the value that we saved, and then draw the quarter circle again. Okay, so from that point on, we save the x, save the y, save the heading, draw the quarter circle, go back to those points, set the heading back to what it was, and draw the quarter circle to get to the start of the next one. Okay, and we're going to do that 4 times. So this isn't ideal. We are doing it 4 times, and whenever you see that you're going to repeat something, that tells you should be using a function instead. So what is it that we're repeating? It's this stuff. So let's put that into a function instead. Def, and we can call it whatever we like. I think in the example it was called circle underscore side. So let's do that. Circle side. We have to indent these things so that they are all fall under the circle side function. And then of course we have to call the circle side function. Now what we could do is take that line, which just takes us to the start of the next quarter circle, and put that there. So what the function then does, circle side, is saves the x, y, and heading. It draws a quarter circle. It goes back to the saved x and y and back to the saved heading, right? Then we move to the start of the next quarter circle, and then we repeat that 4 times. But now you see that we are actually repeating this line 4 times as well. So instead of doing that, let's just chuck it in here. Then we don't need to repeat it 4 times because it is getting repeated inside the circle side function. Okay, so that should do it. We're calling circle side. It does those things, comes back here. We call circle side again, goes in there, does those things again, and that happens 4 times. There we go. That's it. I don't see anything else to this. So do let me know if this makes sense or doesn't make sense, or if there's anything that I skipped. And then I can always make another video for you or expand on that specific topic.